Good morning students, welcome back. In this video we are going to learn something about the optics. So many terms and phenomena we have already learned about the optics in previous classes. 10th standard, 9th standard, you all have learned what is reflection, refraction, prisms, laws of reflection, formation of real and virtual images. In the previous classes we have learned so many things about this. Now in this 12th standard we will learn all this thing in detail. All the topics are covering in this chapter. You can see on the screen so many laws along with so many terms which are new also. For example, you know what is telescope, microscope, but how it works we will learn in this chapter. Total internal reflection, reflection everyone knows, laws, formation of mirage, etc., dispersion. So now let us deal or learn all this thing quickly and study further about the reflection and reflection by various surfaces. First, reflection of a light. Before starting that, let me say the law of the reflection, that is the angle of incident of equal to the angle of reflection. And second one, incident ray, reflected ray and normal drawn from the point of incidence are in the same plane. That is for revision for your 10th standard. Most of the things you see, in fact you can say whatever you can see is because of the reflection. Much of the light incident on the object is observed, but some is reflected. The wavelength is reflected light determines its color we see. When white light hits an apple, primary red wavelength color light are reflected while others are observed. That's why you can see the object. Here the object considered as an apple. The ray of the light heading towards the object is called incident ray. If it's reflect of the object, that is called reflected ray. And the perpendicular line of a point on the surface is called normal, and the angle between the incident ray and normal is called angle of incident, and the angle between the reflected ray and the normal is called angle of reflection. Now again quickly revise the law of the reflection which I said. In that we all this term like angle of incident, angle of reflection, incident ray, normal drawn to the incident plane, etc. are being used. Again revising the law, saying that the angle of incident is equal to the angle of reflection. Incident ray, reflected ray and normal drawn at the point of incident are in the same plane. This law are applicable to the curved surface also. You can see on the screen what is incident ray, where is the reflected ray and where is the normal line. That is I is equal to R. Now reflection of a light by some object. Considered when light comes and bounces off a non-smooth surface. There, law of reflection is obeyed, but because the surface is not smooth, the normal can be pointed the different for every ray. You can see on the screen that if it's regular surface, the normal is simple, but for the irregular surface, the normal is not simple. If many light rays strike on non-surface, they would reflect in many different directions. This explains how we can see even when it is a light shining upon it does not reflect in the direction of our eyes. Before starting the topic, you should know the phenomena like speed of light, reflection, refraction, etc. You have learned in the previous standards that light almost travels with the speed of 3 into 10 raised to 8 meter per second in vacuum, but it changes its velocity when it's moving from one medium to another. For example, third-fourth of when it's travel in water, 2/3 when it's traveling in gas. It happens because light strike with an atom, it must interact with the electrons cloud. If light travels from one medium to another, and if its speed is this medium differs, then light is subjected to a refraction, changing of a direction at surface. Refraction of a light waves and refraction of a light rays. Reflection and refraction, two different phenomena. The interface between a two medium, both reflection and reflection can be occur. Angle of incident, reflection and reflection are all measured with respect to the normal. The angle of incident and reflection are always in the same line. The light speed up upon the entering a new medium, and the angle of reflection theta r will be greater than the angle of incident, as it depends, or you can say it moves with respect to the medium. You should also know the few terms like what is pole, principal axis, aperture, principal focus, focal plane, focal length, etc. when you are dealing with the reflection of a light by mirrors or mirror-like surfaces. Center of reflecting surface of a mirror or mirror-like surface is called pole. The imaginary line passing through the pole and the center of curvature is called principal axis, as you can see on the screen. Aperture, diameter of a reflecting surface is called aperture. The point where the rays parallel to the principal axis meet or appeal to meet after reflection is called principal focus of a mirror. The plane passing through a principal focus or normal to the P principal axis is called a focal plane of a mirror or mirror-like object. Focal length, the distance between the pole and the principal focus of a mirror or mirror-like object is called focal length. You can see on the screen what is incident ray, reflected ray, normal, reflected ray. In what is happening in reflection and refraction, there is a vast difference. See, on the green side, the bending of the ray is changed, and on the blue side, the bending of the ray is different. Why and how? That is with respect to the medium. Now just imagine you are on a skateboard heading from the sideway towards some grass at angle. In front of an axle is deducted before and after entering the glass. Your right contact of the glass at first and slowly, but your left wheel is still moving quickly on the slight walk. This causes a turn to a normal. If you take from glass to sideway, the same path would be followed. In the case of your right wheel would be reach to a sidewalk first and speed up, and your left wheel would still moving slowly. This result a time would turning from the normal. Now think about the what is the cause of that. It is a index of refraction, and a subject or substance is the ratio of a speed of a light in vacuum to the speed of a light in that of the subject, in that of that substance. N is equal to C upon V. C is the speed of a light in vacuum, V is the speed of light in medium. Even you can compare with respect to the different medium. See, for vacuum it's 1, air, water, ethylene, gas and diamonds are given on the screen. Now here the important things is why and how the light changes its direction, that we will learn in this video. Also remember the tips that eta or mu of optical rare medium is lower and that of denser medium is higher. So here the nu of denser medium with respect to the rarer medium is more than the 1, and that of rare medium with respect to dense medium is less than 1. So you can write as mu IR is equal to mu Vc, that is for the vacuum, and air is equal to 1. In reflection and in refraction, the change of the velocity and the wavelength of light depends on the medium. Refraction, the frequency and the phase of a light do not changes. You can further or different way you can also write as mu is equal to Ca upon Cm and mu is equal to lambda A upon lambda M. The principle of reversibility of the light says that mu is equal to sin I upon sin R, that is law which you have already discussed. So in two different mediums with respect to A and B position, you can write just these two equation which you can see on the screen. But also remember that the law of refraction says that the incident ray and the refracted ray and normal ray drawn to the point of incident are in same plane. For the two given medium, theta 1 and is the angle of incident and theta 2 is the angle of refraction, the ratio of sine I upon sine R, or you can say sine theta 1 upon sine theta 2 is constant. The ratio is called refractive index or just an index. You can even write in terms of n is equal to C upon V, that is giving you the terms like n21 is equal to sine theta 1 upon sine theta 2, that depends upon the medium, the temperature and the wavelength of a light. The refractive index of medium with respect to vacuum is called absolute refractive index. The ratio of the absolute refractive index of medium 2 to the absolute refractive index of medium 1 is relative refractive index of a medium, which can be represented as n2 upon n1 is equal to sine theta 1 upon theta 2, gives you the equations that n1 sine theta 1 is equal to n2 sine theta 2, or you can write in terms of n1 sine I is equal to n2 sine R. As you can see on the screen, the denser medium has its role. So I and R will changes with respect to the medium you have taken. For example, you can see on the screen for the slab. But you know that sine I and sine R, reflected and incident angle. Thus, by just solving the equations in that manner, sine I upon sine R multiplied by sine I upon sine R, you will get as 1. It implies that your sine I is equal to your R2 and your sine I2 is equal to your R1, since I1 is not equal to R1 and I2 is not equal to R2. That is also a proof of a law. In other way, you can say that N21 is equal to V1 upon V2, that is 1 upon N21 is equal to V2 upon V1 is equal to N1 2. So at last you can say in that manner your N21 multiplied by N12 is 1. That equation is the general result for the more than 2, 3 or more medium. You can also write in that manner your N31 is equal to N32 multiply N21. Now what happens when the shift is said to be a lateral shift? You can get the equation y is equal to t sine theta upon cos r, or y is equal to t sine I minus r upon cos r. Now what is mean by lateral shift? As you can see on the screen, the ray of the light traveling in the rarer medium, homogeneous medium remains in the same medium. It moves from one part to another and enters into slab. It will twice reflect at the surface, and thus point merge ray is one ray and not the previous one. It is clear from the figure that your N21 is equal to 1 upon N12. Thus, you can say in that manner your emergent ray is parallel to the incident ray, but due to reflection it is a shift by some amount. Such deviation of a incident ray is called a lateral shift. Now think for an example. Suppose a shift is such that you can get the equation that your moment or your y is equal to t theta 1 upon 1 upon n2 minus n1 case. Then also the result can be vary. But the special case is like when your I is very small, then R1 is also very small, that is sine I1 minus R1 is equal to sine I minus R1 is equal to I1 minus R1, and cos R1 is equal to 1 will give you y is equal to t I minus R, or y is equal to t I1 bracket 1 minus 1 upon mu b. Now that is another example of refraction. It is our common experience that object inside a bucket tank or lake filled water, when we viewed outside it appears to be erased. The phenomena of refraction is responsible for this. The figures seen that what is the reason for the change of the position for the object when it is in the one or two different medium with respect to the air as one medium. It can be in two different mediums, two or more different mediums. Here the role is of the depth, that is a real depth of objects, and virtual depth will be different with respect to the observer. One of the other example is for the same phenomena is sunrise is 2 minutes earlier and sunset is 2 minutes later than its actual event. This phenomena is related with your horizon or apparent position and actual position difference due to refraction. All the equation related to that is seen on the screen. Generally first three are same, just the differences in the position, because it is moving from rare to denser, then again other denser. At last you can say that the multiplication of all these three will be equal to 1. or of other two will equal to third one. Now see, apparent depth of a liquid. You can see on the screen that actually light is traveling in straight line. Then you see from the top, it should be seen at point O, but you will see at O dash, or vice versa, depends on your supposition. Now suppose the object inside the water and views of eye of a person, there will be a person eye. With respect to the position, the image seen will be at different point. Now see, you can see on the screen that this much distance is different. That is your change in the actual and real image. Even you can think that there should be change with respect to observer, real depth and apparent depth. Now for the apparent depth of a number of the immiscible liquid, you can just think that or write as HA is equal to summation of HI upon mu I. As you already know that your apparent shift is equal to HR upon HA is equal to HR minus HR upon mu, which can be related as H is equal to HR bracket 1 upon 1 minus mu or N. The Sneen's law is one of the important law regarding the, or you can, when you are dealing with the refraction, the ratio of the absolute refraction index of the medium second to the absolute refractive index of a medium 1 is relative refractive index of a medium 2 with respect to the medium 1 is equal to n2 upon n1 is equal to sin theta 1 upon sin theta 2, which can be represented as n1 sin theta 1 is equal to n2 sin theta 2 or nr sin theta r, depends on your suppositions. As the light goes from rarer medium to denser medium, the ray of the light, which makes an angle of reflection, is smaller than the angle of incident, and the ray bends towards a normal. But if theta 2 is bigger than theta 1, or you can say that your theta 2 is not much bigger, or other way you can say that your n2 is small than n1, or sin theta 1 is small than sin theta 2, the angle of reflection is greater than the angle of incidence, so the ray of the light goes from denser medium to rarer medium, bends towards a normal, and vice versa case if it's moving away from the normal. Now see how the law can be derived. Two parallel rays are shown in the diagram, opposite to each other. A top pair is one point at one time. and the bottom pair after time t. So by using the mathematical laws, you will get sin theta 1 is equal to x by d, that is x is equal to d sin theta 1. Sin theta 2 is equal to y by d, that is y is equal to d sin theta 2. And you know the speed of A, that can be written as v is equal to x by t. Similarly for B, you can now compare or take the ratio of v1 and v2, will give you x by t upon y by t is equal to x upon y is equal to sin theta 1 upon sin theta 2. So just by simplify, you will get your n1 sin theta 1 is equal to n2 sin theta 2. Remember, previously we have just simply taken the ratio of v1 upon v2. In second term, we have placed the value of v1 and v2 which we have derived or obtained from the figure. There are few problems. For example, you have a kind of diagram or object which bends in this manner, considered a prism. Now you have to find the angular displacement of a ray after it passed through a prism. These are the hint for the sum. First find the angle of reflection, then find phi, then find second angle of incident, then find the second angle of reflection using Sneen's law. This is a kind of sum you have to try yourself. The solution will be given in next video.